Welcome to part 2 of your lesson today. So now that you know what a critical number is, we're going to look at min and max values. Again, there's nothing new. We learned about min-max values back in grade 11 pre-cal when we learned our quadratic functions. We graphed them when we tested them. But now we're going to use our calculus language and knowledge to explain a little bit more min and max values. So again, it shouldn't be too hard. So min and max values of a function, we're going to talk about something called extrema. We've never used that term. So very simply, remember grade 11 pre-cal, we drew our parabolas, our mini parabolas. Some of them went down, some of them went up. So we knew from grade 11, they go down, there is a max. If the parabola goes up, it has a min. So let's use some language, calculus language, to define that a little bit more. So how do we define that that's a min? Well, we say if f of x is greater than f of c for every value, then that point will be a minimum. That makes sense, right? This is the lowest point. Every other value on that function, every f of x will be greater than that value. This is the lowest point you will have on the graph. That makes f of c a minimum. And same here, what if your f of x is less than f of c? That means all these points are lower. F of c is the highest point you'll have on the graph. That's what it's saying. Every other point on the graph will be lower than f of c. And if that's true, f of c is going to be a maximum. So that's stuff that we already know, maybe just kind of explained a little bit different. So we should know the concepts of min and max values from grade 11 pre-cal. Whoops. Then the next page, extreme value theorem. So we've never talked about that. So if f is continuous on a closed interval, then f attains an absolute max value, f of c, and it will have an absolute min value, f of d, at some points c and d in the interval a, b. It's kind of wordy, but nothing too hard about that, right? That's just a min and max value in a closed interval. And I'll show you a graph on the next page that maybe explains that a bit better. So that's called the extreme value theorem. So how to get extrema of a function? So the extrema of the function will be the min and max values, which we learned back in grade 11 pre-cal, with the y values of the endpoints. So when we did our polynomial graphs last term, remember we graphed them, and I said in grade 12 pre-cal, as long as you get the x, y intercept, the end behavior multiplicity, that was enough to get full marks. And some of you asked, well, do we need to know those values of the min and max terms along the way? And we said no. Well, now the answer is yes. So when we look at a graph, you can see you have more than one min and max values for polynomial graphs. So in this example, we have 1, 2, 3, 4 max values. But you see, all the max values are at different spots. So out of the 4 max values, this max is the max. It's the highest max value. So this would be the absolute max here. So only one max is the absolute, the highest, the maximum. So these, we would call them relative max. So you have relative max, and the highest max is the absolute. Same thing with minimum. This graph that I drew has 3 minimum values, but you'll notice the minimum of the minimum would be the absolute minimum. So this is the absolute or global minimum, and then the rest of them we would just say they're relative minimum. So some new language, I don't think that's hard. And again, the interval a, b, that's our closed interval. We have all these different min or max values within our closed interval a to b. So Fermat's theorem, again, we didn't do any theorems in grade 12 pre-cal, so let's look at Fermat's theorem. So f of our function has a local min or max at c, and if the first derivative of c exists, then the first derivative of c equals 0. Well, we've talked about that already, right? We started unit 3. What does the first derivative of a function give you? Well, the first derivative that gives you the tangent line at that curve, right? So if the slope of our tangent line, the first derivative is 0, grade 10 pre-cal, remember we learned our slopes of lines? Everything's connecting in this from grade 10, 11, and 12. So if you have a slope of a line is 0, we know from grade 10 pre-cal, only horizontal lines have slopes of 0. So if you have a horizontal line at the tangent line at the curve, then you know you have a min or max. So we're putting everything we learned together from grade 10, 11, 12 into calculus. Like I said, nothing new, just kind of explained a different way. And just to make note, you can only have min or max values at critical numbers or at endpoints of a closed interval. So it looks like kind of a lot of language and wordy, but actually nothing we haven't really talked about since grade 10. Okay, we're almost ready for the example. So how do you find the extrema? So step number 1, find all critical numbers, which we learned how to do in part 1 of this lesson. Then once you have the critical numbers, you find f of c. Not f prime c, f of c for each critical number. So you test each critical number in the original function, but it's not just the critical numbers, you also have to do the endpoints as well. So you test the endpoints and the critical numbers into the original, and then you look at their y values. Very simple. The largest y value tells you that's where your absolute max is, and the lowest y value gives you your absolute min. So it's a lot of, what do you guys use? Plug and chug. So after you get the first derivative, just a lot of plug and chug. So really going back to grade 9 math. So nothing new, we're putting all the pieces together. That's why I love math so much. Everything we've ever learned has a use. Okay, so our one and only example today. Our original function is 3x squared minus 10x plus 7, and the endpoints, the closed interval goes from -1 to 3. So step number 1, we need the first derivative. Oh, this is easy for us. That is 6x minus 10. And then we need to get the critical values. What values of x make this equal to 0? So for the critical values or critical number, we have 1. Our critical number is 5 over 3. 10 over 6, which simplifies down to 5 over 3. Okay, now here's the fun part. We get to plug and chug. So I wrote maybe a little bit too big. I'm going to divide my screen in half. So we put these into the original, not to the derivative of the original. So the order you test them doesn't matter, but our first endpoint, our interval starts at -1. So you will replace all the x's with -1 from the original. And I'm going to save you some time. Hopefully my numbers are right. If I've done that correctly, when I replace all the x values with -1, I get a y value of 20. Okay? Then I'm going to test, it doesn't matter the order that you do it. Then we had one critical number. So now I replace, instead of replacing the x's with -1, I replace all the x's from the original with 5 over 3. So yeah, it's going to be a lot of fun mental math, but that's okay. And again, I'll save you all the steps, and hopefully I did this correctly. But when you replace all of the original x's with 5 over 3, I had a value of -4 over 3. Okay, then, so I've tested that endpoint. I've tested my one critical number. Then I have to test the other endpoint. Now I go back to the original function and I replace all the x values with 3. And again, if I've done my math correctly, that gave me a value of 4. Okay, so you test your endpoints and all the critical numbers into the original function. And don't let anyone tell you calculus is hard. We're looking for the biggest number. The biggest number is 20, so that would be where my max is. And the lowest number I have is -4 over 3, so that's my min. Wow, calculus is hard. We're looking for big and small numbers and plug and chug. Now, to put our answer out fully, oh, I have a little bit room. So the absolute max, again, remember we're leading up to graphing, so we need to know the coordinate points. So our absolute max, it occurs at -1 and 20. And where did our absolute min occur? Again, we will be graphing, so we need to know the coordinate points. Where would we graph this point? When x is 5 over 3, the y value is -4 over 3. So it's long and tedious figuring that out, but the concepts aren't that hard. And again, we're going piece by piece because eventually in 2 weeks' time, we're going to put all these together in one super long, massive question that combines our limits, our derivative rules into one, and we'll find our asymptotes, our min, our max, our inflection points, the concavity, and we're going to make a nice polynomial and rational graphs with a lot more detail than we did back in last term. Okay, so you're ready for part 2 of this lesson on your min and max values. Have fun.